Now we're going to take a look at eliminating a variable in equations in order to solve the system of equations. Remember, a system is when you have two or more equations. And you can solve them in a couple of ways, such as graphing or substitution, as you know. But there's also this elimination where you literally eliminate one of the variables by adding or subtracting the equations. Right here I see a negative 3x and 3x. If only I could add these together, they would go away and I'd have no x's. And you're actually allowed to do that. You can add these two equations. So I'm going to do plus. Negative 3x plus 3x is just 0. They're gone. 4y plus a negative 6y, or minus 4, take away 6 is a negative 2, so that means there's negative 2y's. And 12 plus 18 is 30. When you divide by negative 2 on both of these, you get y is equal to negative 15. And then we need to find what the x value is. So I'm going to take that negative 15 and put it into either one of the equations. I'll put it in this one because then it'll cancel out that negative. So 3, I don't know what x is, so I can't put that in there. But minus 6, negative 15 equals 18. 3x plus 90 equals 18. When I subtract 90 from both sides, I get 3x equals negative 72. And when you divide that by 3, x is a negative 24. So I get x equals negative 24. There's that negative. Y equals negative 15. But that's not the answer because it's not in the correct format. You need to put it so you have the x value followed by the y value in parentheses to show that it's an actual point on a graph. It's the coordinate point where these two lines actually intersect. And that would be our answer in the correct format for it. If you do it like this, you will lose a point on my tests. Now we can do the same type of thing over here, except we can't add these two, because if we add them, we're going to get 8x. But because they're the same, we can subtract. 4x take away 4x would be 0. But when we subtract, people often forget to subtract the next ones. Many people would look at this one and do 2y minus 3y is negative 1y. But you need to notice that it's minus a negative. I like to put them in parentheses, put the entire polynomial in parentheses to emphasize that there's a negative out here. So that makes it 4x minus 4x. This is 2y minus a negative 3y. Minus a negative is a positive, so that makes it plus 3y. 2y plus 3y is 5y. 28 take away 18 is 10. So y is equal to 2. Now I can take that 2 and I can put it back into one of these. Doesn't matter which one. I guess I'll just take the first one. Let's put 2 in for the y is equal to 28. That's 4x plus 4 is 28. When I subtract 4, I get 4x is equal to 24. And dividing by 4 tells me that x is equal to 6. So I get 6 for the x and 2 for the y. Now, both of these problems don't require you to make any changes to the equation. But this next one does, because right now you cannot add or subtract this one and be able to get an x or a y. You will not have eliminated either one of them. So if we're going to eliminate, we need to do something to either get the x to be a 2x or a negative 2x, or to make this one a negative 3y. And actually this one you wouldn't really want to change, or that one. We have two choices. To change the x so it matches or is the opposite of 2x, or to put a 3 with that one. I like the idea of making this one a 3 because then I can add them together. See, subtracting is perfectly fine, but I personally prefer adding. So whenever possible, I set them up so I can do that. So This one, I'm going to multiply it by the number 3. And that means I get 6x minus 3y is equal to 27. Here, I'm going to write that one underneath it, the same one. And now I'm going to add these. So I get 7x, this becomes 0, and 27 plus a negative or minus 6 is a 21. When I divide by 7, I get x is equal to 3. And now I'll plug that 3 back into either one. I guess I will put it into this one here. 3 plus 3y equals negative 6. Subtract 3 from both sides, and we get 3y is negative 9, and divide by 3, y is negative 3. 3 and negative 3. This is actually the same as one of the problems in the substitution section, and it shows that oftentimes the things in substitution you can just as easily do by elimination. Sometimes the elimination ones are not as easy to do by substitution, but we'll get to that in the next problems. But notice here, you can simply add or subtract. Here you have to change one of them, and then you can add or subtract, in this case to add them. Now let's take a look at these problems, because in these, what you have is a different thing where you cannot add or subtract, and I can't change one of them. I have to change both of them. I either have to make both of these 24 or 48, that would be harder, or I can make both of these 15. So I like working with the smaller numbers, so I'm going to change this one to make 15 each, and this one to make 15 each, or for 15 there, 15 there. Okay, I'm going to do this and then show you something that can also make that a little bit easier. So changing this makes it 30x plus 15y is equal to 30. And changing this one is 24x plus 15y is equal to 12. I just made a mistake. Purposely made the mistake, but I did make a mistake. A very common mistake that people often do when they're doing these problems. I multiplied 3 times 8 and 3 times 5, so I have the correct coefficients for the x and the y. I forgot to multiply 3 times the constant on the other side. 3 times 12 is 36, so I'm going to change that to 36. But I did that on purpose to show you that it's a very common thing, easy thing to miss. And I have found that to be true in the past and wanted to make sure you were aware of it now so you won't do that mistake. It's more a matter of just being very careful. Now, I can't add these because I would get 30y, so I'm going to have to subtract them. 30 of these, take away 24 of them, looks like 6 of those things, or x's. These are 0 now because it's minus 15y minus 15y. And 30, take away 36 is negative 6. And when you divide both sides by 6, you get x is equal to negative 1. Before I go on and find the y, let me point out that I could have chosen to make one of these a negative, and if I had made one of these a negative, then say this one, I would have had negative 24, negative 15, and negative 36, and I could have just added them. I think I'll do that in the next one to show you. If I put a negative 1 here for here, let's put that into this first one. 6 times negative 1 plus 3y is equal to 6. Negative 6 plus 3y is equal to 6. Add 6 to both sides. 3y is equal to 12. Divide by 3 and I get a 4. So negative 1 and 4. And that would be my answer here. And now in the next one, and now on the next one here, I'm going to do this. I'm going to multiply. Now, here's the thing. I'm going to have to multiply both, but I could choose to make this 20 and this a 20, or this one a 15 and this one a 15. I'm going to go with the 15s again, just because of the smaller numbers. This time I'm going to use a negative for one of them so that I can add instead of subtract at the end. Watch how it works out. This one becomes 15x plus 20y equals 30. This one becomes negative 15x minus 25y equals 35, and now I can add them. This becomes 0. 20 plus a negative 25 gives me negative, 20. Oh, I made a mistake. Good thing I caught it. 3 times 4 is 12, not 20. Good thing I caught that before it made big problems for my adding. And here I get a 65. When you divide both sides by a negative 13, y is a negative 5. And now we'll plug that back in over here. 5x plus 4 negative 5 is equal to 10. And that gives me 5x minus 20 is equal to 10. When I add 20 to both sides, I get 5x is equal to 30, so x is 6. So I get an x of 6 and a y of negative 5. So both of these show you pretty well how you can change them and then subtract or change them with one being a negative, and it enables you to add, and all depends on the numbers that you get. There's one more problem on here. Okay. Oh, this one says 1 and it should be page 2. So here on page 2 there's one more problem. Try this one on your own. Do either one of those methods. Well, do it by elimination, but do either both positive or one of them negative when you multiply, and figure out what to do with it. And then when this is posted in Dropbox and in Google Classroom, then I will have it all worked out so you can see if you are correct. If you're watching this on video now, then just check the paper that's printed out and you will see it.